In this video, I want to do a quick trace of the insertion sort algorithm. So let's start here. We have some inputs, right? We have our question prompt here. Trace include initial state followed by the state of the arrays after each pass is made. We'll go over here and we'll just start right by writing that initial state. And my goal is going to be to basically sort this entire array. All right, so this is what I'm looking at. And initially, what we'll say is that this is all unsorted, and then our sorted region is basically just empty. Okay. So yeah, let's try running or simulating insertion sort on it. So insertion sort, normally I look at kind of this first element, and I try to add it to the sorted region. So looking here, right, 7 is my first thing. Well, in that case, basically it'll shift it to the left into the sorted region. Really, it doesn't even require me to do any work. I just leave it there. And then yeah, I'm done with the first iteration of insertion sort. And I'll go ahead and write in these. So this is the stuff that's kind of left behind. So sorted versus unsorted. I'll do this again. Right, look at the next element, 23, shift it into the sorted region to put it in sort order. In this case, again, things are going to be easier for us because it's already where it's supposed to be. It's already to the right of 7, and 7 is smaller than it. So again, sorted is on the right, unsorted is on the left. Do this again, look at the 25 again, we don't have to do any work. It's already in our sorted position. Right, sorted, unsorted. And I should probably annotate here, right? So these first leading ones are the ones that we're going to be moving each time. All right, so next one, right, we're going to look at moving the 13. This one's going to be a little bit more work. So 13 needs to be shifted to the left. Now here, right, normally what happens is 13 would be swapped to 25, and then it'd be swapped with 23. You keep on swapping it until you get to the place that it's not out of order. I'm going to not put those arrows though because it'll make my drawing very cluttered. So here, right, if I were to draw this in, let's see, 7, 13, 23, 25. Okay, that's now my sorted region, and then my unsorted region is 2, 12, 5. We'll do that one more time, right? So now 2 is the one I'm looking at. This one, right, is going to take a lot of work. I have to shift it all the way to the left. So you can imagine I'll do like 4 different exchanges. We'll just pretend that I don't know how that became a 5. We'll just say this has been a 3. Let's pretend this has been a 3 all this time. There you go. And then I guess one more time, right? So we're almost done, right? We've almost sorted everything. Here, right, we need to move our 12 into the proper position, which means swap, 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 get it between 7 and 13. So my stuff would then look like, I need 12 there. 12 there, 13, 23, 25, 3. Sorted, unsorted. Last thing, right, is a 3. You would do shift, 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 right, to get between 2 and 7. All right, all sorted. So yeah, then that ends up being my final result. So in this case, right, I need to do 1, 2, 3, 4, 5, 6, 7, 8. Basically 8 different traces, right? Because I'm starting with unsorted, right, and I have to do 7 different moves to move everything to where it actually belongs. So yeah, there you go. That's an example of simulating the insertion sort algorithm on an input.